H2S, the thiobacillus, is what is affecting all of our products. It's destroying concrete structures at rapid rates. In fact, ACI, American Concrete Institute, says once a pH level of their concrete product has hit a pH level of 9, it can lose upwards of half an inch a year in product. So imagine that if you had your concrete driveway and you lost half an inch per year, you'd be very unsatisfied. The municipalities need to be the same way, with maintenance costs and rehabilitation costs going off the charts. We need to get ahead of this problem. And to do so, we have to come up with sustainable solutions. So today, our job is to introduce polymer concrete to you, but it's important to know what's causing that. So that ACI report that we talked about talks about these, but let's get right into the first one there. That blue line represents inflow and infiltration. That's caused from the water that's getting into our systems. Now, municipalities, engineers, and contractors are getting better at this. We're now using laterals, or our units that are transferring our sewage from manhole to manhole are now usually PVC, HDPE, or fiberglass. All of those are inert to corrosion, and they allow minimal amounts or no water coming into there. That's a good thing. The bad side of removing inflow and infiltration is H2S levels are going up because we're taking out that dilution factor that is keeping the H2S levels low. So you remove water, H2S levels go up. So that's what we see with the green line there. H2S level is on a rise. And then lastly, if H2S and thiobacillus are growing at a rapid rate, in fact, unprecedented rates, our costs of maintaining our systems are uncontrollable. Every municipality our sales team goes to says they do not have the time or the people to go and look at every single structure they have in their grounds. And that they know that they're failing at high rates, but they don't have the money or the people to maintain those. That's the exact reason you went to PVC for your laterals. And then lastly there, you see the gray line at the bottom. That's the concrete specification. Most municipalities have not updated their specifications for access structures, wet wells, manholes, etc., for 70 plus years. And yet that red line, the one that represents the dollars coming out of your pocket, it keeps going up. It's time to make that change. Let's do a quick introduction to what we are and why we're here. Armorock started as a little tiny company out of Utah, of all places, Orem, Utah, in fact. And we had 3 precast operations in Utah. We made precast concrete structures. In fact, we made the ones that you're going to see in this video. The gentleman in the blue shirt there is 2nd generation from that company. His name is Vince Bushio. He and his son, 3rd generation, developed polymer concrete as Armorock knows it today. They developed this because the Band-Aid options that we used weren't working. Municipalities would come to us over and over and say, hey, this is what's happening to your manhole. You can see you can see the product breaking down. The white starts showing through. It becomes white and spongy. And they would say, you got to give us something better. So Vince went and did what anyone would do in the precast industry, and they bought a lining company, and they would spray line our project. They would spray line our manholes, and inevitably that coating would fail. And then we tried cast-in liners, and we found that that liner would fail due to ultimately it was installed incorrectly. We didn't weld the joint properly, or I&I would push it off the walls. And then lastly, we tried admixtures. Now, if any of these 3 items were to work, Armorock would not be here today in the level that we see. And so that's the problem in a nutshell. So now let's get an opportunity to go into what those Band-Aid options look like, what you, the municipality, see. While we're waiting for this to finish, remember, if you have Q&A, please write them in during this. If you have a question that comes up that pertains to what I'm talking about at the moment, I will answer it immediately. If not, we'll answer it when we get to the Q&A at the end. But we can stop and take some time here, so feel free to ask questions as necessary. So those Band-Aid fixes that we talked about, we'll start with the one on the left. Those are spray liners, and those are typically done for rehabilitation levels. So if your product has already failed, then you'll go in and spray coat it and hope that works. Interesting part about spray coating is that's not a structural liner. So a municipality is not fixing the solution. Remember, if you have a product that's deteriorated, it's no longer an ASTM standard. It's not even to the thickness that the ASTM requires. So putting a rubber coating on there does not solve the problem. It does slow the corrosion, but it does not solve the problem. You can typically see those in pinks, greens, blues, grays, etc. Secondly is HDPE liners. In fact, I'm in my vehicle right now. I just left a job site and we were looking specifically at these HDPE liners on a project. And the first thing that they tell you is if they're not installed properly, that theobacillus, that bacteria that you can't see with your eye, gets behind the walls and disintegrates the product behind it. And that can be caused from simply installation being wrong. It can be caused from a contractor cutting through that HDPE liner, etc. The last ones there are admixtures. Interesting concept there, but in their own literature, when you're looking through their literature, they show that it can only hold up to certain parts per million. In fact, most of them can only hold up to 70 parts per million of H2S to 100 parts per million. Seeing that I'm from Florida, when the municipalities that we work with here use otologers, I'm sure lots of you have heard of otologers. That's a product that you put in your manhole for 7 days, and it's a data collector. And it's reading the levels of H2S, and it reads it from a high to a low, and it averages it out. Here in Florida, we're seeing low averages in the 300 plus, and we've seen high averages in the 2000 plus. Either of those numbers are going to kill you if you're in that structure. So as a company, we had to abandon these Band-Aid fixes very quickly because it was not making our concrete structures sustainable. And that's where we are today. Dalton, please change the slide. This is just an example of what product looks like when it fails. On the far left one, you can see an HDPE liner has clearly failed, and the concrete behind it is now becoming white and chalky. At this point, I&I, inflow and infiltration, is free to travel through and around that liner, and the concrete's failing at a rate that product will implode on itself if not replaced. Interestingly enough, the warranty of that HDPE liner did not cover the concrete on that structure. The concrete has a 1-year warranty. HDPE liners typically have a 30 to a 50-year warranty, and it didn't cover the concrete behind it. So you, the ratepayer, us, the taxpayer, had to replace that project. The one in the middle there, you can see liner pulling away from and separating. That's on a new structure. That gateway for H2S and theobacillus is created, and it's not even in service yet. And then lastly, you see admixtures. Admixtures fight off the amount of H2S they can, and when it's overwhelmed, then the theobacillus has its way with that structure, and you see the product implode on itself. Now, I'm excited to announce Gary. Gary Carter is in Northern California. Gary, in your area, tell us a little bit about some of the concerns California has with failing infrastructure, and then at that point we'll then go into what is the answer and how does polymer solve these problems.
Great, thanks, Jared. As you mentioned, I live in Northern California, and lately we've been experiencing very heavy rainfall and precipitation throughout the state. In fact, I'm on a job site now. We're installing a 144-inch diameter wet well that's been delayed because of the rain. And as I sit in my truck right now, it's beginning to rain. So we're going to be delayed a little bit longer. Hopefully we'll get the installation in tomorrow. But as Jared mentioned, heavy rains can place a significant burden on our sewer systems. So as you take a look at the photo in the slide, on the screen, we see an image that is a common issue in many systems across the country, as well as California. High costs due to inflow and infiltration, also known as I&I. I&I is when groundwater and stormwater enter a sewer system. And this really becomes a problem when the stormwater and groundwater mix with sewage. This happens when sewer systems are overwhelmed and potentially overflow. As the volume increases, the systems and manholes can become damaged when they're forced to transport more flow than they're designed to handle. For instance, when you're driving around and you see a manhole bubbling over with water, this is an example of it. Infiltration occurs when groundwater seeps into the sewer pipes through the cracks, joints, or deteriorated manholes. And inflow is stormwater that enters the sewer system through basement sump pumps or foundation drains. A more severe condition is called exfiltration, when those cracked sanitary sewers or manholes leak out and contaminate groundwater or surface water. This is a big deal because it can cause an environmental risk. Discharge of untreated wastewater into the environment can result in heavy fines from the EPA. Not to mention the public relations nightmare that will have to be handled. California is a very environmentally conscious state and takes these incidents very seriously. But let's pause for a moment. Let's fast forward in time. We're in the summer months where precipitation is low. The sewer systems are back to normal, managing the normal amount of flow. When this happens, as Jared mentioned, there's going to be a decrease in I&I. And when I&I decreases in a sewer system, the result is an increase in H2S gas. As he mentioned, less dilution of the sewer water. The consequence is an unintended consequence of less dilution is, and decreased I&I results in a higher concentration of H2S gas. So in the previous slides that Jared showed, we see what happens in those sewer systems because the Theobacillus immediately impacts and begins the corrosive efforts. These are two extreme examples that occur over time in a sewer system. I'm going to hand it back over to Jared. So he's going to explain how Armorock Polymer Concrete can resolve both of these issues. And he's also going to break it down and tell us exactly what it is. Jared?
Thanks, Gary. Yeah, that's really exciting to talk about what's going on in our system. In a moment, I'll talk a little more about that. So what you see here is actually a test that's based off a test out of California, Gary's backyard. This is called the pickle jar test. It was, you can find that in the California Green Book. It's one of the more advanced tests for testing for corrosion. And in this case, it's a simplified version of it, but we use a muriatic acid. In fact, a 20% muriatic acid, which you can buy at any pool store. The reason we use muriatic acid, because unlike H2S, it's a visual effect. So you see the bubbling taking place. If the product is bubbling, that means there's something in there that can be corroded. So if there's steel in there or an aggregate source or concrete, it fails at a rapid rate. And then you can see in return the polymer solution. Now we haven't got into the recipe yet, but you'll understand the science of why polymer works. But for this purpose is that visual test. As this is running, Gary is talking about H2S in the summertime of California getting worse. It's actually getting worse across the board in every state and continent in the world. And the reason why is because of the sustainability our municipalities are working towards. As you build systems that don't allow an I&I, like those pipes, the laterals from homes, which used to be black iron, they'd be concrete pipe. Those days they're all PVCs. They're inert to I&I, and in return, we see H2S levels going up at unprecedented rates. If you want to fast forward another year or two down the road, in every municipality across the nation, where you used to have 4 homes on 4 acres, now we see 4 acres of apartment buildings, and you have 4,000 people where you used to have 16 people. So now we're condensing that H2S in these massive systems that are blowing up concrete structures at record rates. Again, maintenance can't keep up with them. So let's give you the full recipe to our product. What is polymer concrete? Well, let's start with the very basic. we're resin. We're resin in lieu of Portland cement. So we removed Portland cement from the matrix and we use resin. This is the same resin PVC pipes are made from. It's a polyester resin. Silica sand in this case. Silica sand has lost all the properties to be corroded and is left behind essentially glass, and that's inert to corrosion. And we finish it off with an aggregate source. In most municipalities, they're using soft stones that are easy to crush, easy to corrode. In our scenarios, we use a granite or a quartz. Those are both inert to corrosion. And to finish off this trifecta, we're going to finish it off with the FRP rebar. Now, this is a ACI 440 rated rebar, and that gives us the ability to have a product in there that says we're 100% corrosion proof. Now, to go into the strengths of our product, it's really simple. Concrete, as we all know, is a very strong product. It's 4,000 PSI per ASTM standards, and it's typically breaking between 5 and 7,000 PSI at 28 plus days. So it's a strong product. But as the science shows, even as ACI, American Concrete Institute, says, it can't hold up to pH levels that drop below 9. In fact, it disintegrates too quickly. So our product in return is actually quite a bit stronger. And this is how we come up with a product that's actually a little lighter. It's a little lighter because our wall thickness is typically half of what you find on a concrete structure. And that's because we're 3 to 4 times stronger in compression. So depending on our mixed designs, you're typically seeing a low of 11,000, a high of 16,000, depending on mixed designs. When it comes to flexural strengths, we see our product again 6 to 8 times stronger in flexural than concrete. And again, that gives us the ability to engineer our product to lower the cost of the resin and give the sustainability municipalities need. Let's just do a quick plant tour as we go through this. This plant that we see in the background, this is in Boulder City, Nevada. We have plants in Sulphur Springs, Texas, and Plant City, Florida. And someday soon, very soon, we'll be announcing several others to come online, but we'll leave that for another webinar. What you see going in the background here is what we call Pico. That is German for woodpecker. Now this machine, we essentially have 3 of them right now. 2 more are being installed currently. This runs about 24/7. And this gives us the abilities to adjust to you, the municipality, to your standards. In the past, as a precaster, we would tell you what we could make and you would have to deal with it. But this gives us the abilities to make exactly what you want. It gives us the abilities to make a bench that's inverted to make sure sewage is always flowing towards the invert, and we can match any slope you require. We can do 0-90s at very tight radiuses, typically much tighter than precast. And the most important here, because we're carving this out of foam, which I'll highlight in a moment, we get the ability to make inverts that are very smooth. The importance of that is to eliminate any agitation to the sewage running through there. If you eliminate agitation, you eliminate H2S coming off of your product, and you can eliminate or at least slow down that theobacillus that's destroying your concrete structures. So as you saw there, we just carved everything out of foam. Now that is only used for molding purposes. That's not used in the final product. Can you pause it right there, Dalton? What you see there is the hard-coated foam. The purpose of hard coating is that now that gives us the ability to keep a library of these. In fact, you can see a library of them on the wall in the background. That's so we can reuse that over and over. Once it's ran out of its useful life span, we'll grind that up, we'll recycle it, and put it back into the system. But you can see there, those are pipe formers. That says what size of pipe is going to be running through that invert. And this is going to go in a steel encasement. This gives us the ability to have our joints upwards of 8 feet in height. So eliminating joints eliminates I&I potential. Go ahead and unpause that, Dalton. Thank you. Once the product's been placed in the mold, you're going to see the product being poured in. You'll also see the reinforcement going in on the bottom shell there. There it is there. This is for a 48-inch manhole. That's the FRP rebar that hits the same standards as traditional rebar. The difference is it's inert to corrosion. Again, 100% commitment to corrosion protection. When you see the product in its final cast, it takes about an hour to an hour and a half for that product to cure out. We can start moving it around our yard in 3 hours, and depending on our mix design, we can ship it as early as 9 to 12 hours from our shop. And when you're done, in return, you have a monolithic base. That base, invert, the anti-flotation collars are all intricately cast into that product. And you see how smooth those inverts are. Again, you want to eliminate any agitation of the fluent so that your H2S does not get created. Thank you, Dalton. Let me introduce Antoinette. Antoinette runs our North Carolina, South Carolina area. And she's just been incredible up there and is doing amazing things. And she's going to take you through some of our products and what you can expect once it comes from the plant.
Thank you, Jared. Hi, everyone. So Jared did a great job there taking us through not just a look at Armorock's polymer concrete recipe, but also a tour of our plant and in showing you guys how we do it. So this is what the result of our efforts are from our plants. If you look here, that what you're seeing is our structure sizes for our round structures, which truly are our signature structures at Armorock. We start at a 48-inch diameter round manhole all the way up to a massive 192-inch structure, which really computes to a 16-foot interior diameter structure. So those are some huge structures. Our motto here at Armorock is definitely, if you can build it in concrete, you can build it in polymer. So we will work with our design engineers and our municipalities on the design. Yes?
Can I interrupt really quick?
Please.
This is Jared
Yeah.
again.
Yeah.
192 inch is a massive structure, and I just saw the question pop up. Someone wants to know, can you ship that anywhere in the country? Just highlight the shipping opportunities quickly, if you don't mind.
Hi, Jared. Yeah, no problem at all. So it's a great question and one that we get asked a fair bit when we're out on the lunch and learn circuit with our engineers, municipalities, and contractors. The answer is yes, we can. If we can build it in polymer, we can ship it all the way up to those 192s. It depends on where it ships from, is going to depend on the plant that it was built in. And typically it's going to ship in separate truckload structures. So to give you an example, you'll see coming up here in one of our next slides that we installed a 16-foot interior diameter wet well in Piedmont, South Carolina. It was delivered from our Sulphur Springs, Texas plant on 3 trucks. It was fascinating to see and to be part of. And I also like to add, when I get asked this question, that it's very carefully transported. But the answer is yes, it can be shipped anywhere in the country with great precision and planning from our logistics team. So just to kind of reference here, I'm going to tie in, we looked at our size structures. Let's take a quick look at our lead times. We know from the feedback we get from the field that lead times are absolutely critical in this industry. And we're very proud to boast that this is another way that we're very, very different from traditional concrete, and that is our lead times and how quickly we can turn around product. As Jared just showed us in the plant tour, our cure times are amazing. So we're at movable strength in under 24 hours on our smaller structures, 24 to 48 hours on our larger structures. So what that does is it impacts our lead times in a big way. So we're able to turn around our smaller diameter structures in typically 2 to 4 weeks. You'd be talking there about your 48s, your 60s, and your 72s. Then our larger structures would be our 96s, our 120s, our 144s, and you're looking at 6 to 8 weeks typically on those. And then our massive structures are our larger ones, all the way up to our 192s. And there we're usually at about 10 plus weeks. What is amazing to note about this is we have then the ability in emergency situations to turn around a product very, very quickly if the municipality, in fact, has what they would call an emergency or an expedited situation. So it gives us a tremendous advantage over traditional concrete.
Antoinette, we have a quick question from John in Oklahoma. He says, does it take a special class or a special instructions to install polymer concrete? In other words, who can install this product?
Okay, so that's another great question. To answer that question, you do not have to be certified in order to install our manholes or structures. If you can install a traditional concrete manhole or structure, you can install an Armorock Polymer concrete structure, but we always do revert to the municipality for their requirements. There are some municipalities across the country that do have a certification requirement, but the general rule of thumb is if you can install a traditional concrete manhole or structure, you can install an Armorock Polymer concrete structure. And just to add to that, which may be helpful, we do get asked questions about our structure installation process. To put your mind at ease, it's actually very similar to a traditional concrete manhole or sewer structure installation. We typically use a base. We use risers or inserts if it's a rehab project. And then we have a chimney or a cone or a flat lid based on the design specification. And it's installed similar to a traditional structure, just in what we call a stack out process. One thing that I would like to offer is if anybody on the call has any interest in having a webinar that is designed specifically to walk you through our installation process, we're happy to do that. So feel free to drop your contact details into the Q&A chat section, and your sales manager for your specific area will be happy to reach out and set that up. But also, one of the things we pride ourselves in here at Armorock is that if we have,
and I'll go ahead.
Sorry?
We have another quick question here that I think is relevant, and if you're, I'll go ahead and answer this one. They want to know what's the weight of our product in comparison, and I believe it's probably because I see a crane in the background there. So, as many of you know, concrete is 150 pounds per cubic foot. Polymer concrete is 140 to 145 pounds per cubic foot, so almost identical in weights. But as I highlighted earlier, our product is typically half the thickness of your concrete structures, and that's because of our strengths. We don't need those same things. So what that means is traditionally we're about a third lighter on installation time. In fact, here in Florida, our products are light enough that we can install a 96-inch lift station traditionally with the same excavator that digs that hole. You do not need a crane. So that gives you, the construction company, the abilities to get products in there. And then lastly, while we're on this slide, and I'll turn the time back over to Antoinette, you see down there in the very bottom, it talks about burial depths. We haven't found the limit to how deep we can go, but Texas, as always, has to do the biggest and best. And they always say Texas is the biggest. They are the biggest. They have done the deepest structure to date that we know of in the polymer industry. And that was a 180-foot deep gravity 16-foot station. 16-foot station is what you see in the pictures there. That's 16-foot inside diameter. And that system was 180 feet deep with a 104-inch gravity sewer line running through it. And interestingly enough, in most municipalities, when you're done with the project, they'll run a camera, which they drag through the pipes. They'll check the pipes for being flat and round, and they'll check the inverts of a manhole. This invert system of the structure was so large, they drove a golf cart through it with cameras on the ceiling of the golf cart to video. Thanks, Antoinette. I will leave the rest of these questions for the next slides.
Okay, thanks, Jared. Just to round out a couple of points here that I wanted to cover is just to reinforce that with our structures, there are no extra steps. So you don't have all that extra prep work and timing and cost of coatings and liners. Our entire structures are built out of our Armorock Polymer concrete recipe from the ground floor up. So they're easy to install. We do provide support for all of our installations. We try to have someone on site if we're working with a new contractor, new partner who has not installed our product before. We want to give you some peace of mind, and we will make every effort to have somebody from our project management team on site for those installations. Or at the very least, we'll have somebody on video call standby, and we do provide video tutorials and some documentation to walk you through the installation process. And then just another quick note. So Jared mentioned the Texas team has installed our deepest structures. I'm proud to say that this 16-foot interior diameter wet well that we installed in Piedmont, South Carolina, is our largest product that we've installed so far on the East Coast. And it was an exciting day to be on site for that. We had drones flying, we had cameras, we had the design engineer, the municipality, the contractor, we even had the developer on site. So it's very exciting to see our product get built. It's exciting to see it get out there on site. And it's most exciting to be on site with the contractors as they're installing it. So we're very proud of our efforts. And then just to close out the loop on the different size products that we can build for you. Obviously, our manholes and our wet wells and lift stations are certainly part of our signature products, but we also can build rehab structures by way of risers and inserts to go with the base if it's a rehab, or a full replacement structure with a monolithic pour if we're doing a replacement. We can build some custom box structures. We've done a ton of them in the past. And we also can do structures of custom shapes and sizes. So what you're looking at here in that image to the far right is what we call a Lego structure. We named it that internally because this structure was so large, it was built in sections and installed in sections. But we work very closely with our partners from the design phase and pre-design phase with the engineers and the municipalities to design and build the structures that you ask for and that you need. So if you have any special requests of products of different shapes and sizes, just again, drop us a note in the Q&A section or reach out to your sales manager. We're going to put that information up here in just a moment, and we will work with you to move forward on your projects. Jared, with that said, I'm going to toss things back to you.
All right, back to life cycle cost analysis. In the bottom left corner, there is a QR code. If you like, take a picture of that, and it will actually give you a calculator to help determine where in your system sustainable products like polymer concrete are needed. So this is a comparison to a traditional concrete manhole. And as you can imagine, concrete is a much cheaper product to install than polymer concrete. You see that in the black versus the red. We don't hide from that price. Upfront costs cost more, but as we all know, and our municipalities are asking us to design for sustainability, you need to look at the overall cost. Most municipalities are reporting where they're having high repairs needed. They need to repair a structure in high corrosive areas between 5 and 15 years per structure. That means in the 50-year life expectancy, you're seeing a manhole, if you have the ability to just keep up with how many times it needs to be maintained, could typically need to be maintained three plus times. Every time you maintain a product, you're losing structure, which when you lose structure means it's not an HL load rated product any longer. And so those costs start skyrocketing. There's a municipality here in Florida, and in their own study of their system, with the amount of corrosion they have, they found that their traditional system, we were break even on their life cycle cost analysis. We were break even with concrete in 7.7 years. That's actually on the high side of what we traditionally find. But so at 7.7 years, we're dead even on cost. At 50 years, we were saving them 70% on a product that doesn't need to be rehabbed and no maintenance costs. And those are only exacerbated when we go into talking about I&I and the true cost of what's going on with that system. Thank you, Dalton. We're having a lot of great questions coming in. We'll cover these probably looks like in the last 10, 15 minutes, but keep asking questions. There have been some fantastic ones so far. Let me turn this back over to Gary. It looks like he's warming up in his car from that freezing rain in California. Gary, tell us where our team is and what's our plans for the future.
Yeah, no, it's not really freezing, but it is pouring, which is unbelievable, which is heartbreaking. Anyway, Jared, we have a high caliber team, and they are ready to investigate your areas and address any challenges that you have. The areas in red represent locations where we have personnel. We think these areas of the country can benefit most from our structures and solutions. The areas in gray are locations we're going to look to build out in the future. However, if you'd like more information about Armorock, please put your name, email, and phone number in the chat, and we'll have somebody follow up with you and reach out to you. Jared?
Thank you, Gary. Let's go ahead and go to that next slide, Dalton. Yeah, lots of great questions. Keep those coming. So we'll have at least, it looks like we'll have at least 10 minutes worth of talking points at the end on this. But let's start with where we see our facilities today. As I mentioned, we started in Salt Lake City, Utah. In fact, we had our first plant in Orem, Utah, and then we quickly started to find where the hotbed of corrosion was, and that was in the southern states. Las Vegas, probably because of all the buffets, their corrosion was off the charts in their sewer systems. Just joking if you're from Vegas, but there might be some truth to that. So Boulder City, Nevada is where we see one of our plants. We also see Sulphur Springs, Texas, and Plant City, Florida. And it says, where to next? We're excited to, maybe that's an early rumor. There's rumors that we have several more plants coming, and soon we'll be excited to announce where those are. What state is in is yet to be seen, or what country, but the growth of polymer is off the charts. Polymer, and the reason it's off the charts is because municipalities identified early on that your current pipe specifications weren't working. So you had to switch to what's working now, which is the PVCs and these laterals that are sustainable. To date, you do not have access structures or lift stations that are holding up to those high levels of corrosion that we're talking about. So adding polymer concrete to that gives you a sustainable wastewater system, eliminating any potential rehabilitation or maintenance. Specifying polymer concrete is really the key here. A lot of times municipalities say, it costs more money to put it in. Yes, it costs more money to buy the product. Actually, putting it in is actually the same price as traditional concrete. It's the money to come. At some point, you have to stop the bleeding and put in products that are working and solving problems. That's where specifying polymer concrete is the true choice. What we see across the country is when municipalities take this, they'll typically go to a phased program. Phase 1 will be 25% of their system will go to polymer concrete. That's typically the lift stations, the junction manholes, the king manholes, drop manholes, force main discharges, etc. We know that the corrosion is there and at high levels. Interestingly enough, though, that theobacillus, even in our system, which is inert to it, is still growing. So eventually it's going to go to those manholes that aren't affected. Why H2S has risen at the levels we are today, I mentioned this a little earlier, is our laterals aren't allowing in water. In California, you have low flow toilets, low flow washing machines. During the days of the droughts a couple years ago, they were encouraged to shower every other day. All of that are dilution factors, which in return increases H2S. Now, to exacerbate the problem, that PVC that we talked about and the polymers, they don't allow theobacillus to eat their walls. They're inert to it. So the product's still being made and it's getting supercharged. So as we become more sustainable, you will naturally need to go to polymer and PVC type items in your entire sewer system, eliminating all concrete. So most people are going to a phased project. If any of you are interested, want to see what some of those specifications look like for municipalities, all the salespeople on here have municipalities and standards that they can share with you and are happy to do that. And then lastly, if you want to see the projects in the ground and see this project, we'll be happy to take you out there and show you what's out there. Dalton, take it away.
Perfect. So for this next section, we have our questions. So continue to put the Q&A in the chat. We have got a lot of great questions in there, and Antoinette will start reading through them.
All righty, we do have some great questions that have come in, and I'm going to just ask these, and our team will answer them. I'm going to cover some of them, and our team will answer them, and in no particular order. But some of these I can see are questions again that we typically get when we're in a lunch and learn environment. So one question we do get asked a lot, the first question that I see here is, can you core through our manholes? And I'll take that one and answer it and let you know that you can in fact core through our manholes. You would core through the same way you would core through a traditional concrete manhole, typically I think using a diamond bit chainsaw. But one thing that I would add to that is, as Jared covered earlier when he talked about our material strengths, because we are so much stronger in flexural strength and also in compression strength, it's going to take you about 30% longer to core through. So just be prepared for that. But you can, in fact, core through our product. And there is a second question that pertains to that I'll go ahead and let's see. It's asking if you core through our product, if it voids the warranty. And I'll answer that one also, since I've just covered the core through question. And the answer is no, it does not void our warranty in any way for you to core through our product. We expect that you may need to, and you can core through when the product is first being installed, or you can go back to it at a later time as you need to and core through the product. So there are no issues there at all. So hopefully that answers that question for us. The next question that we have is, and Jared, maybe this is one for you, is if polymer concrete is corrosion proof, then why do we use fiberglass rebar?
That's a great question. So if your product was to establish a crack or any sort of damage and you create a gateway, which then the water can penetrate those walls, and if there's steel in your product, the steel in return will corrode and swell. And when the steel swells, then you're going to have spalling of your product. So interestingly enough, we have two reasons we use fiberglass. One, it's inert to corrosion. And number two, it expands equally to the polymer concrete, expands and contracts equally. As we all know, concrete expands and so does steel, all products do. And that's why we have heave lines or cut lines in our driveways, so those can expand and contract without breaking the driveway to pieces. So our product needs to work together with our infrastructure so that we have the strengths needed to eliminate any cracking for potential I&I or spalling of that product.
Very good. So another question that has come in, and I'll answer this one also, is we're being asked if we are ISO certified, and I am proud to say that we at Armorock are ISO certified 9001. So we do meet those certifications, and that is also a question that comes up frequently. So another great question. Yes?
I see the one from Wesley there. He's asked a couple now, a couple of really good ones. Number one, he wants to highlight buoyancy. As we mentioned earlier, our product is typically about a third lighter than traditional concrete structures. The way we account for that is with the geotech reports. When we do our submittals, we see what those geotech reports are of the jobs, and we design all of our structures to have a minimum of 1.5 anti-flotation calculation. Most municipalities require a 1.0. We actually have upped that to 1.5. Our anti-flotation collars are monolithically poured on the smaller structures, 48s through 72s. They're monolithically cast into our product, and we can make them wider or deeper depending on those calculations to make sure nothing will ever pop out of the ground.
Great answer, Jared. Another question that we've had come in is, what does a rehab process look like for our Armorock structures? So I can speak to that one. Jared, you may want to chime in on it, but I would say that we as we referenced earlier, have the ability to do either a rehab project, or we can do a replacement project. It's going to be based on the structural integrity of the structures that have to be replaced. In a rehab scenario, you would use your existing base of the product. You would rehab the base using a cementitious product and allow cure time and then coat that with an epoxy. But we would then come in with our Armorock risers or inserts, and that would be the new walls of that rehab structure. However, if you were doing a replacement project, then you would remove the old structure in its entirety, and we would build that with a monolithic pour and deliver that on site. So Jared, I don't know if you want to add to that or if that covers that question adequately.
Spot on. You have that one well. I will take one here while you're going through those questions. Let's see, I have a couple. Number one from Matthew. What sets you apart from other manufacturers that utilize polymer concrete? That's a great question. Number one, there are lots and lots of companies that are going to be producing polymer concrete over the next handful of years. That's because it works. If it didn't work, believe me, no one would be going into it, because it costs an absolute arm and a leg to build these plants that can produce this product. What sets us apart? We're the largest polymer producer in the world now. We can produce at rates no one else can do. We use a fiberglass bar in our product in lieu of steel, which some other manufacturers use. We believe that being 100% inert is an important part of this. When I talk about competition, I do not want to say that they're making bad products. They are making good products, but they make it differently than we do. So competition is good, and inevitably it makes prices more fair so that you aren't gouging markets, and it gives us the ability to grow at higher rates. As everyone knows, as a municipality, it's very difficult to do a sole source specification for one producer. So having competition is good, and we have some good competition. But our speed, quality of product, and our white glove service definitely sets us apart. So great question, Matthew. And then I'm doing one more here. I saw, let me squeeze through here. Let's see. What is the age of your oldest polymer structure, and has it shown decay? Our oldest polymer structure under the name of Armorock actually is in 2008. And a couple years ago, we did a webinar highlighted that structure, and no, it has not shown any signs of deterioration. And in all reality, we can go look at that anytime and you will see. The science, that pickle jar test we showed you a little earlier, shows that the product will not fail in the system. So for us, that's very easy. Anytime someone wants to go see an old structure, bring it on. One of the oldest structures I personally have seen was in Yuma, Arizona. And if I have my story right, I went there with a municipality here from Florida because they wanted to see firsthand these old structures. On the way there, the municipality asked the Yuma, Arizona municipality, how long has this product been here? And they said, well, we're going to see the golden manhole. And right away they said, what is the golden manhole? And why do you call it the golden manhole? And they called it the golden manhole because they had replaced the manhole 4 times in 5 years or rehabilitated it, something along those lines. They'd spend a huge amount of money on the process here. And they found that when they put in the polymer concrete, they put it in and they went and looked at it the first year. And at the first year, the product looked perfect as advertised. This municipality saw that contractor 5 years after they hadn't seen it for 5 years. They popped the lid and it looked as perfect as the day it went in. There is nothing in the sewer system that will deteriorate polymer products. Go ahead, Antoinette, back to you.
So I think, Dalton, it looks like we may have time for maybe one more question, because I know you've got some things that you want to do to round us out and finish us up for today. So I thought that this question was a great one for us to finish on. And it's a question that's come in asking if we've ever had to do a warranty on any of our structures. And I'm proud to say that we at Armorock, as Jared said, started installing our products in the ground under the name of Armorock in 2008. Since then, we've installed over 20,000 structures in the ground across the entire US, and to date, we have not yet had to do one claim for corrosion against our warranty. And I think it's just a really strong statement to make, because I think the 50-year warranty that we talked about in the opening of our session today speaks very boldly about the confidence we have in our product, in our team to build our products, and in the service we put behind it. So I thought that was a good one to finish on. With that said, Dalton, I'm going to toss it back to you to round us out, and certainly appreciate everyone's time and participation today.
Dalton, before you get started, I'll just finish off with one more thing. This is Jared in Florida again. We will be emailing everyone, obviously, and Dalton will go over that, but we'll follow up with emails. If any of you have feedback for us or have lunch and learns that you want to have in your municipality or your engineering office, again, reach out to us or respond to the email we send you. And we'll be excited to work with you and your municipalities. And then lastly, when we built this company, started in 2008, they did it on the backs of Vince and Mike Bushio, and they did that by putting pilots across the country in the highly corrosive areas across the country. And they went out there, put the product in the worst case scenarios where we could prove product quickly. We're excited to show that to all of you in future webinars coming up. And thank you for joining us. Dalton, finish us off.
Perfect. Thank you, Gary, Antoinette, and Jared. I really appreciate you guys speaking today. Thank you, everyone, for hopping on and listening to who we are as a company and what polymer concrete is. So like Jared just said, if you have any other questions, please feel free to put it in the Q&A chat. Scan the QR codes if you would like to give us feedback or are here for PDH credit. But that is all from us. So thank you all for attending.